This is a demonstration of how to perform mechanical texture analysis of salmon fillets. In particular, the aim is to measure firmness by the use of a Warner Bratzler blade and also tensile strength, which correlates closely with the propensity for gaping in the samples. First aim is to cut two 4 cm by 4 cm square blocks, which will be used for firmness analysis, and then two slightly longer 8 by 4 blocks, which will be used for the tensile strength. The accuracy of the dimensions of these cuts is incredibly important because any deviation in these dimensions effectively influences the amount of sample you're testing and thereby can bias the recorded texture values. And that's the two firmness blocks ready and the two tensile blocks ready for further analysis. This little mould is used to check the dimensions of the firmness blocks. With any deviation, if that box isn't filled properly, you can assume it's not correctly proportioned. Then cut the top off using the mould as a guide to ensure the sample is of uniform depth. So now that is boneless and uniform, ready for analysis. Very important, check the alignment of the muscle fibres. They must be perpendicular to the blade, so the blade cuts through across the muscle fibres. This is a Warner Bratzler blade, so it's a blunt-edged V-shaped blade. The face of that blade is 3 mm flat face, so it's not sharp at all. The texture analyzer is now going to travel downwards at 2 mm a second for a predetermined distance. And there's a sensor inside the arm which records the resistance produced by the sample, which is how texture is then calculated. When the blade's travelled down its predetermined speed, which in this case is 50 mm, it returns to its original position, ready for the next test. Tensile test, the longer sample is mounted on these two spikes. Now the skin needs to be pierced, so we use a block of rigid foam just to apply uniform pressure until the skin is punctured by the spikes. Use a pair of surgical scissors to carefully cut the skin, avoiding cutting any of the meat. Now the machine is run as before, but in reverse, moving apart at 2 mm a second and recording the resistance of the sample. You see the sample begins to break, usually along the connective tissue junctions between the muscle blocks, effectively measuring now the force required to rip apart that meat. And you'll usually notice that the meat breaks quite neatly, exposing the collagen sheets between the muscle blocks, which is where gaping occurs. And the end result is these force time plots, which can subsequently be analysed to calculate values of maximum force and work required to perform the movement.